Day 146, Honors Physics, Kirchoff's Law is example number 4. Once again, these problems are tailor-made for people who like to solve puzzles, like Sudoku puzzles and the like, because it's like these little things you got to look for and little patterns, but the basic ideas are similar every time. For example, on a complicated one like this, what I did at first is I labeled my junction points, especially point A is a junction and B is a junction. Everything else is a reference point. A, B, C, D, E, and F. C, D, E, and F are just references for when I do loops. But A and B are truly the only junctions where a bunch of wires come together. Three or more wires come together. I've been assigned the currents in these branches. I know that from A to C to B is 6 amps. From A to B is 2 amps. That was given. From A to F to B, that was designated I sub 2. And then from B to D to E to A was designated I sub 1. That's that blue arrow right there. All right, so some things that are a little bit different about this problem. There's a lot of loops here. I'm going to do 3 loops out of the 6 or 7 loops that are here. You can count them. Yeah, I think there's 7 loops, 6 loops. It doesn't matter. Anyway, the first loop I'm going to attack is, as I have on the very right-hand side over here, is loop A, B, D, E, A. A, B, D, E, A. And all I'm concerned about is that square, basically, that I'm outlining right now. I'm ignoring everything else. I'm ignoring this branch right here within that loop. This branch that goes to F. I don't really care about that. I'm just looking from A to B to D to E to A, and I'm ignoring everything else in this entire diagram. And there's only 2 elements there. I'm going to have V1 plus V2 up here at the top, V1 plus V2. Well, V1 is this resistor I come to in the middle from A to B here. Well, I know the voltage there is 2 times 30 is 60 volts. And you'll see a lot of shortcuts maybe in this problem as we go along. But 2 times 30 is 60, so from A to B I have my conventional current down with my direction of travel here. So it's negative 60 plus my generic battery V over here on the right side equals 0. So V must be 60. This voltage here must be 60. What you're going to find in this problem, basically you have 3 branches in parallel with each other. This branch here, this branch here, and this branch here. Each of those branches must have 60 volts total within that branch. You'll see that as we go along here. Alright, so then I did loop ACBA. ACBA. So I can do loops that don't have batteries in them. So there's my loop. I can go either way, but I'm going to go counterclockwise this time. And I have 3 elements. The first element I come to is this 4 ohm resistor. I'm calling that V sub 1. Well, once again, it's 6 times 4 is 24 volts, but it's negative because I'm going with that blue arrow. That's why I get the negative 24 over here, V sub 1. Then I have my voltage for this resistor right here. I'm going to call that V sub R, or V sub 2, either one. So I'm calling it V sub R, generically V sub 2, same thing. And then I'm going up from B to A. But when I go up from B to A, now I'm traveling against my blue assigned current arrow, the 2 amps. So therefore, instead of being negative 60 volts here, it's going to be plus 60 volts for this particular resistor. So that's why I get negative 24 plus, minus the V sub R unknown plus 60. So V sub R has to be 36 volts. And if V sub R is 36 volts, that can apply Ohm's law to this resistor, because I know there's 6 amps in that resistor. That blue current, or current, coming from here to here is 6 amps in that branch. So I'm applying Ohm's law to that unknown resistor. The unknown resistor is now known. It's 6 ohms. All right. Once again, there's like 4 other loops. I'm going to pick loop ABFA. ABFA. And there are shortcuts. One of the shortcuts could have been in this particular loop, ABFA, is that since this is one series combination here, I could have put the 5 and the 10 together to make 15 ohms. I didn't do that, but I could have. So if I go for ABFA, I have 3 elements. Element number 1 is going to be this resistor, then this resistor, and then this resistor's voltage. So I'm calling that V sub 1, V sub 2, plus V sub 2, plus V sub 3 equals 0. That's my loop ABFA. Let's see if I can move this up here. Yeah, let's try this. Okay, now what I'm going to do then is V sub 1 is going to be negative 60, and then plus V sub 2. Well, actually minus V sub 2. No, it's going to be plus because I'm going against the blue current. So my current is coming down from A to F to B. and I'm going around the loop this way, opposite that current now in this branch, so it's going to be plus that voltage. But what is that voltage right here? I don't know. I don't know the current or the voltage, but I can express the voltage as V equals IR. In other words, I times R. The I is I2 and the R is 10. So, well, let me write that down over here just to show you. I have V equals IR, generic Ohm's law, but in that 10 ohm resistor, it's unknown V10, which equals I is I sub 2, times that 10 ohm resistor. That's the only thing I know is a 10 ohm resistor. Well, the voltage then is 10 times I sub 2, expressed in terms of I sub 2. So in other words, I'm going to take that expression and plug it in for V sub 2. So it's going to be minus, and I'm going to put the 10 first because that's the way you normally express terms in algebra, minus 10 I sub 2. And the same thing for the 5 ohm resistor. It's going to be minus, I'm sorry, it should have been plus though, because now I'm doing the unconventional. I'm going against the current flow, which is coming down from A to F to B. So it's going to be plus 10 I sub 2 plus 5 I sub 2. That's what the voltage is if you use this expression over here for Ohm's law for the 10 ohm and the 5 ohm resistors. Well, bottom line, it's an equation with one unknown. So you solve that, you end up with negative 60 plus 15 I sub 2 equals 0. Solve for I sub 2. I sub 2 comes out to be 4 amps. All right, that's part of what we need to solve in this problem is the I sub 2 is 4 amps. Now we're almost done because it's real simple at this point, if you see how the pieces are fitting together. What I'm going to look at here is point B right now. At point B, I have three currents coming in. The 6 amps coming in, the 2 amps coming in, and now I know that this is 4 amps coming in. It's a total of 12 amps coming into point B from these three branches. 6 plus 2 plus 4 is 12 amps coming in, and the only outlet is this I sub 1. So I sub 1 must be the 6 plus the 2 plus the 4, all in amps. That's equal to 12 amps in that branch going through that battery, the only battery in the diagram.